Hello everyone, today we're going to be talking about Taylor polynomials, more specifically a general overview and an example of how it works in everyday life. So basically the basic formula for a Taylor polynomial is the summation of n is k equals 0 in this case. That's kind of the standard. Now n is typically k. Now this doesn't make sense, but that's because n in this case is typically going to be infinity. And then you've got so f of the derivative of k, so whatever k is, times a divided by k factorial times x minus a to the power k. And basically spread out, it looks like this, where you have just the function itself at a derivative of a times x of a to the power of k, which is 1. And that just continues on until you get the formula back. So basically, a great example for me anyway is a calculator. So how does a calculator do a graph? Well, it does it based on Taylor polynomials at a fundamental level. It breaks it down and is able to do it a lot more efficiently than doing the math just plain out, especially when you're taking derivatives and integrals and stuff. It's faster for the calculator, especially when it has a slow processor. For example, let's say you want to do the function of f of x at sine, and in this case it's going to be centered at x equals 0. So this would also be called a Maclaurin series because it's centered at x equals 0. Don't worry about that. Don't worry about that. Don't worry about that. And then the degree would be the derivative, but we're not going to do that out. So basically, what a Taylor series is at a fundamental level is basically draw tangent lines, but really tangent functions. And what I mean by that is, well, let's just look at this graph that I will draw freehand and probably be very bad. So basically we're going to just draw the function out. And so obviously a sine wave looks like this. That was pretty bad, but oh well, it's basically, and then let's say you're going to do a normal tangent line, and that would be just the first derivative, and you get something like this. Not very accurate, and it's not going to accurately depict what you're trying to show. But a great thing is Taylor polynomials just become essentially a tangent. So, for example, let's say you take the third derivative. Now the third derivative will kind of look like x to the third. And what I mean by that is it'll look kind of like this. So it'll kind of follow it, but it's not that close. But the more and more derivatives you take and the more you add them up, the better approximation you get to the function itself. And that's what a calculator does for weird functions. For example, y equals sine of x. Also, I realized I made a mistake. Don't worry about that. It's not a Maclaurin series. It's a Taylor. Don't worry about that. I just realized I was wrong.